So I expect about maybe around 15 of you might show up, because on an average there are about 2 or 3 absentees in each batch. So roughly around 70%. So since, yeah, roughly, I think I can see about 14 of you. Okay. Okay. Yeah. Please turn on the videos, please. Let me share screen. Right, all pages. Let's sit here. Okay, all right. I think we have to start with that homework, permutation combinatorics practice 3, right? So let's start with that. So first one, Claudia has 12 coins, each of them, blah, blah, blah. 17 different values can be obtained. Okay, yeah. So I can see you first on the screen. We're able to do this.
Sir, I started with it, but like I just didn't find a way because it was taking very long. I was doing it manually, so
right.
I could get to a final answer.
Okay, fine, no worries. Why are several videos still off? Shivank, Vihan, Ananya, please, guys. Sanvi, I think you're using your mom's. Okay. So I was just going to say Kajal, and then I saw it's you. Shivank, Suhani, please, all of you. Okay, all right. I'll pass it on to Arav. Arav, we're able to do this one. Claudia, am I sharing screen or am I not? I'm not.
No.
Okay, no, I am. Yeah, go ahead.
I got C5.
Okay, can you explain what you did?
Oh, yes. So I first set the amount of 5-cent coin she has as X.
Okay.
Therefore, she has 12 minus X 10-cent coins.
Okay.
Then I set up an equation which, so since it's only 5 and 10, the total number of coins must be divisible by 5.
Correct.
It must. And so I created an equation and then I obtained my answer. I'm not sure. It took me a long time. It's very messy.
Okay. All right. So yeah, more or less the same track only. Okay. So just a couple of small corrections. Really does not matter. See, finally he's asking how many 10-cent coins. So I'll use this variable as X, right? So that at the end, suppose you forgot to flip it back or something, you don't have that chance of that silly mistake. So always try to see if the variable can be what's asked. Not always it will work out. If not, you have to be cautious at the very end that you are actually doing the necessary subtraction or whatever it takes. The other small, again, very, very small thing. Generally, X to me is a real number, right? M, K are all integers. Since we are talking integers here, get into the habit of choosing appropriate variables. Again, it may not matter at all, but like involuntarily in the brain, it will affect you, right? When you're dealing with other problems. So choose letters like M, K, A, these for integers, right? And for real numbers, you have X, Y, Z and all that. Okay. So very, very minor point. So let's say M number of 10-cent coins. And as you said, there'll be 12 minus M of these 5-cent coins. Okay. So the total value for this would be 10M plus.
So it's the other way. I think there's M 5-cent and then 12 minus M.
No, I am keeping M as the number of 10-cent coins.
Oh, okay, yeah.
That was my first explanation. The reason I'm calling this as M is because that's the final answer. You can keep this as M, that is 12 minus M, no problem. But in case you forget at the very end, let's say you get M equal to 8. Then you must remember that 12 minus 8 is the correct answer. In the haste, you might put 8, right? So my first advice was choose whatever is asked as the variable of choice, right? So he's asking how many 10 cents. So let that be the variable, the starting variable, and everything depend on that. Okay. So that was one suggestion. The other suggestion was using letters appropriately. Integers ke liye M, real numbers ke liye X, Y, Z, all that. Okay. Anyway, so 10M plus 5 times 12 minus M. This is the total value, right? So as you rightly said, I can take 5 common outside. So the value is 5 times 2M plus 12 minus n. Okay, 12 minus n. Okay, so effectively the value is 5 times 12 plus m. This is the total value. Total value. Okay, so again, let's deal with small numbers. Yes, we acknowledge that there are multiples of 5. I can change the problem as well and then say these are like 1-cent coins and these are 2-cent coins. So the value, the problem does not change at all, right? So essentially, I can completely forget this 5 out of the equation. So I'm just think of, I have only 1-cent coins. I have a few of them and I have a few of the 2-cent coins and how many different values I can make, right? So he says there are 17 different values that can be obtained. So the total value will be 12 plus m. For example, if I put m equal to 4, the total value would be 16, or in a scaled problem, 16 times 5. I'll just stick with 16, right? But suppose m equal to 4. What does that mean? I have 4 of these 2-cent coins. So 2, 2, 2, 2, 2, 2, 2, 2. And then I have 8 of these 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, so just as an example, just always try to have 1 or 2 small examples so that you can see. So with this, what all can I make? I can make any number 2, 4, 6, 8. Plus, I can insert any number here by adding like a 1 extra. I can do 1, 3, 5, 7, 9, all of them, right? By using a few 2s and an additional 1. On top of that, at the fag end, I can keep adding however number of 1s. So I've covered till 8 all numbers. Till 8, everything is accommodated. And then you have, I can keep adding 1, 1, 1, 1, 1 more. So that is how many of them? There are 8 of them, right? 1, 2, 3, 4, 5, 6, 7, 8. So 8. So 1, 2, 3, 4, 5, 6, 7, 8. Plus, so these I've covered by doing 2, 4, 6, and 8, just using 2s alone. And then these I've covered by inserting an extra 1 to an even number of 2s, right? In addition, I can have 8 more numbers, right? I can have 9, 10, 11, all the way till 16, right? So I can cover 16. So in other words, I can see that for me to cover 16, I had to keep 4 of this and 8 of this. So just by a very quick trial and error, you can say if I increase this by 2 and if I decrease this by 1, then by the same logic, I can cover all the way till 10 here, 1, 2, 3, so on till 10. And then additionally, I have 7 more to go all the way till 17. So I'm sorry, maybe I didn't explain it too well, but it's fairly obvious that I have 5 of them that takes care of all numbers till 10, at least the even numbers 2, 4, 6, 8, 10, and each of the odd numbers also by inserting an extra 1 as needed. And then after you have exhausted all the 2s, I have flexibility to cover every single value after that just using 1s alone. So I've reached 17. Okay, now if you go for more, then obviously you'll be able to do more choices. More number of values. Does this make sense, guys? Bihan, does this explanation make sense to you? Okay, you also got the same answer. Okay, so therefore, what is the final answer? M equal to 5. M equal to 5 was the answer. Okay, now let me ask another variant question on this one. So I will ask. In this case, there are 17 different values can be obtained. Okay, so what is the maximum number of different values that you can obtain? Okay. So in this case, it's 17. I can have an example where I can do only 15. I can have an example where I can do 18. What is the maximum number of different values? And what will be the number of 10 cents in that case? Yeah. Anyone, Navya?
No, so I'm still calculating.
Okay. All right. Okay, Rohan, you have something?
I just joined. Could you repeat the question?
Oh, so just a modification to the original question. So we just discussed the original question where 17 different values are
Yeah,
possible.
I've done this question.
Instead of 17, suppose, can I have a bigger number? Can I have 18? Can I have 19? What is the maximum number of values?
Okay.
Anyone who's done it, you can raise your hand or call it out. Yeah, Harya, go ahead.
I got 23,
23. And that will correspond to m equal to
11.
m equal to 11. Exactly. Yes. So if I have 11 of these 1 cent coins or 5 cent coins, whatever, 11 of these 2 cent coins or 2 or 10, whatever you want to call it. If I have 11 of them, and then you just have only one of the smaller one, let's say 1 cent, then I can generate every number, every even number is possible, 2, 4, 6, 8, all the way till 22. And then I can insert however number of ones in between. So every odd number is also covered in between. And then plus I can go for 23 as well. So I can cover all the way from 1 to 23. That's right. So this expression more or less follows as m increases, I can have more and more. The only trick is you cannot set everything to be 2s. If you put all of them as 2s, then you lose all the possibility of covering any odd number. If you're too greedy and keep everything as 2s, then you have only back to only 12 possibilities. So it'll keep rising and then suddenly it'll have a fall. Right? Does it make sense? Okay. All right. Question 2. So I wanted to ask one other thing on this one, but I forgot now. Fine. Okay, maybe this question 2, I faintly recall it was there in some other homework as well. But we can go through it again once more, because I remember doing in one of the homeworks, recent homeworks. Veer, do you recall this problem recently from some other homework?
I believe we did a similar problem in
Okay,
previous homework.
all right. Do you have an answer on this one, Veer?
No, sir, I had exams.
Okay, all right. Shivank, how about you?
Yeah, so I got B 7/72.
7/72. Okay, Yuvam, what did you get?
Sir, I got 1/36.
1/36. Okay, all right. Yuvam, Apur, what did you get? You're on mute, Apur. I cannot hear you at least. No, something wrong with the audio. Okay, Navya?
I also got 7/72.
7/72. Okay, all right. So Yuvam, can you explain how you got 1/36, please?
So what I did was, first I rolled the dice. So first roll can be anything.
Okay,
So it's 1, the probability of getting that.
okay,
Then it's 1/6, because the second one needs to be the same as the first one. Then again it's 1/6.
Uh-huh.
And the fourth one is 5/6, because this one is for only 3 possibilities exactly, like at least 3, so it's only 3. So it's 5/6 plus 1/6 times 1/6 times 1/6 times 1.
Okay. So explain the first one again. So you're saying the first coin can be anything, and then you're forcing the second and third to be the exact same thing. And in the last one, you're going easy. So you're saying it can be why 5/6 for the last one?
It can be anything except that one.
Excuse me, sorry. Anything except one.
Except the one which we got in all the previous 3.
Okay, so you're forcing that exactly 3 of them
Yeah,
are same,
yeah.
and the last one is different. Okay, all right. And then, so this is exactly 3, you're saying, exactly 3.
And in the other one, I'm doing exactly 4.
Exactly 4. You might as well write 1 into 1/6 into 1/6 into 1/6. The first one is right, just for symmetry.
Fine.
Yeah. So you meant 1 into 1 6 into 1
Yeah.
6 into 1 6. Okay. There's a flaw in this. Rohan, can you identify what the flaw is?
So to account for all the permutations, you have to multiply by 4 for the first one.
Exactly. Yes. Apurva, did you have same thing to add or same thing?
No, so I did it slightly differently. So I took the total number of cases as 6 to the power 4, and then in the numerator you can say
Actually, before we go to that, can you find the flaw in what he did? Or was it exactly what Rohan was saying also? It's important to understand what flaws people can commit. So my question right now to you is, identify the flaw in what said. That's all. I don't care about your method right now. In UM's method, do you identify a flaw? Actually, Rohan called it out correctly, right? So it was, I thought you had something more to add to that. Yeah. So basically, Rohan is saying, you're forcing that sorry. Okay. You're forcing that the last one is the different odd one. The other 3 are the same, right? But literally, any 3 of them can be same, and the 4th one can be different for exactly 3. So for exactly 3 matches, according to you, A should match B, which should match C, and none of them should be same as D. But what if B is the odd guy and A, C, and D match? That's also possible, right? Does it make sense, Yuvam?
Then wouldn't that be 1/6 into 1 into 1/6? It's the same thing, right?
Yeah, but you have to do them as separate cases, which is why he's saying you have to take this first one and multiply this by 4. Because
Oh,
that's
okay.
the only modification that you have to do. So the first one becomes 5 times 4 in the numerator, and nothing changes in the denominator, right? So it will become 21 upon 216, which simplifies to this 7. 3 goes 7 times, 3 goes 72 times. Okay. Apurva, yeah, can you go through your method, please?
so instead of making 2 cases, what I did was I said the total number of cases is just 6 to the power 4.
Okay.
And then the cases that are favorable are 6 into 1 into 1 into 6.
6 into 1 into
1 into 6.
Okay, what is the 6 into 1 into 1 into 6, please?
So like first case, anything can happen. Like in
Mhm.
in the first roll, anything can happen, right? And then the other two, any two, you can arrange them in any order. They need to be the same. And then the fourth one, instead of making a separate case, you can multiply it by 6, and that includes everything.
Okay. So which means you get the 1/36 as well here.
Yeah.
Okay, there is a flaw in this as well. Can someone else identify the flaw? Rohan, instead of you, someone else, please. Navya, can you identify, or anyone actually, can you identify a flaw in this method? Okay, so what Apurva was saying is, first one, I have complete, he's doing just number of cases. 6 power 4 denominator, that's very clear. Numerator, first one can be anything, any 6. Second and third should follow the first. And then the fourth one can be any of the 6. Yeah, Navya, go ahead.
Similar to the previous method, you again have to multiply by 4 because there's any way you can do, like there's a lot of ways in which you can do it.
But if you do multiply by 4, I'm not getting the same answer, no? Even if you agree to multiply by 4, it still does not match, no? So the numerator in this case would be, so forget the ignore 1 of the 6 power 3, ignore 1 of the 6. It's 24 as opposed to 21 in the other method. Yeah, Navya, agree? Okay, Rohan, yeah.
So you can't take it as one case because there has to be 2 cases, because you have to also account for when it's all just the same value, right? And also the case where it's 3 the same value and 1 not. So you can't do that.
Yeah, correct. Just to expand on that a little bit. So again, Apurva, more or less similar to what Rohan is saying, you're forcing that the second and third should follow, right? So for example, let's say, what is this? These are the, at least 3 of the 4 dice have the same value. Okay, let's say the value that comes here is A. Okay, the value that comes here is A, the value that comes here is A, and this value is B. So that is accounted in what you're saying. This is also accounted in what you're saying. But what is not accounted is this, right? If it's A, B, A, this is not accounted, right? You're forcing the second one. I mean, you did not have the times 4, of course, which is why your answer was a smaller number. The numerator was 6 instead of 21. So you have to split into 2 cases. There's no other way. Okay, does it make sense, guys? Navya, your question?
But then if you would use like the approach you said, like the flaw which you pointed out, you're just saying that like the B can be in any case, like it can be in the first
Correct.
case.
Correct.
It doesn't multiplying by 4 make that like reduce that chance.
But then you should not multiply the A case by 4. A case is only 1. Right? So some get multiplied by 4, some do not get multiplied by 4, which is why 6 was too small, but 24 was too big. The correct one was 21 in the numerator. Does it make sense? Yeah. Okay. All right. Let me just change the question a little bit. So instead of at least 3 of the 4 dice, suppose we say at least 2 of the 4 dice show the same value. Can you all do this question now? So the only modification is I've changed 3 to be 2. Okay, anyone? Kunsh, anything?
So just give me 1 minute. So I'm just doing the calculations.
Okay. Yeah, you guys should have been done by now, guys. Come on. 30 seconds more. Please wrap it up.
Yeah, I got 1,111 by 216.
111 by 216. Okay. All right. Any other answers?
So I'm not sure because it's quite a weird number, but 121 by 1296. I don't think it's right, but that's what I got.
121 by 1296. Okay. Only one small thing I'll say, right? You know, this answer is 7 by 72. The expected answer, therefore, should be higher than that, right? Correct? Because at least 2 means you're making it more flexible instead of at least 3. Or are we making... yeah, we're making it more flexible, right? Therefore, should be a higher probability.
Yeah, so it's around the same value, which means...
correct. So this is 0.1 and this is up around 1/10 as well, right? Okay, let's do it. Yuvam, yeah, you had something?
Sir, I'm not sure what I did. I think it's wrong, but I got 141 upon 6 raised to 3.
6 raised to 3 is 216. Which are, okay, 141 by 216. Okay, Arya,
I got 101 over 216.
101 by 216. Okay, all right. Okay, cool. So let's discuss, right? So at least, what is the probability that at least Mhm.
So I got 270 upon 1296.
270
Yeah.
upon 1296.
Yeah.
Okay, so it looks like one of the 6 can cancel, right? So let's do that also. 6 4s are 24. 45 upon 216. Shall we say that? Okay.
Yeah.
Okay. All right. Let's see. So what is the probability that at least 2 show the same value, which means it's just simply 1 minus all 4 have same value, have different value, sorry. So this is easy, right? This way. So it's 1 minus, the first one can be anything. The second one has to be different from the first. The next one has to be different from the first 2. The next one has to be different from all of them. So the one that I have here is the probability that all 4 have different values. So if I subtract that, that means there's at least 2 which are the same value. So it's much easier this way. So how much is this? It's 216. Maybe I can just cancel off here itself. 6 goes 2 times, and then 6, 3, and 2, I guess, right? So it's 1 minus 10 upon 36, is it? Am I right? Oh, one more 2 can cancel, right? What am I doing? One more 2 can cancel. So 1 minus 5 upon 18. 1 minus 5 upon 18, which is 13 upon 18. Okay, does it make sense? Oh, does it simplify further? Let's see. Another 3 can go, right? 3 goes, 9 can go, in fact. 9 goes 5. 9 goes 2. Why am I struggling with subtraction, division? 5 by 24. No, it's off, right? 13 by 18 makes sense, guys? The approach makes sense? Do any of you strongly believe your method might be convincing, but you're not able to find the flaw? Then we can discuss that method.
I think that's the case with me.
Meaning you are not convinced. You're not convinced. So if you yourself are not convinced, we don't have to discuss. But if you are strongly feeling that something, I'm not able to find a mistake, but I feel it's right, then I can discuss that answer.
So I feel that only what you said.
Okay, then tell me your method, please. Then we'll discuss.
So it's similar to the previous one, but it's an addition of a case, which is exactly 2. So it will be.
So basically, you're doing exactly 2, exactly 3 you've done, exactly 4 also you've done. Okay, I mean, or because we combined those 2 together, and the previous step is 7.72. Now you're doing exactly 2, correct?
Yeah.
And then you want to add that to this and see whether you get the same answer. Okay, that's also fine. Okay, go ahead with exactly 2.
So it's 1, because the first one can be any, I'll multiply later, but the first one can be anything, into 1 upon 6.
Okay.
Into 5 upon 6, into 4 upon 6.
Okay. Times what in this
Times
case?
6.
Times 6. 6 because?
3 factorial.
Why 3 factorial?
Because there are 3 different cases. It can be arranged in any order.
So there's A, B, C. Okay. So we just have to pick which 2 might have the same, right? Sorry, Rohan, your hand was up. You wanted to say something?
Sir, I was doing the same method and I didn't finish in time because I realized that if you're doing this, the 4 by 6 is a little tricky because you have to also think about, it says at least 2 are the same, right?
Yes.
So it will also be A, B, B. So you have to do.
He's doing exactly 2. He's doing exactly 2. So he's doing the case where A, B, and C.
Oh, so with A, B, B, then what would you say? At least 4 of the dice show the same, then it doesn't show the same value, right? So it's still under the same question, right?
So A, B, B should also be accounted.
Yeah. That's why I stopped.
Yeah, that's a good one. Yeah, in fact, I didn't think about that, but I was just missing the multiplication factor here. Okay, but let's do this method also and see whether we get the same answer. So let's do this approach. So exactly 2 ke liye, oh sorry, exactly 2. Sorry, exactly 3 are same, exactly 4 are same, exactly 2 or same ke liye, okay, this is a weird case where you have 2 and 2. Okay, yes. Okay, let's do both of these cases separately. Okay, so let's do the cases where there are 2 of the A's and 2 of the B's, where A is not equal to B. A is not equal to B. So in this, so it's I find it easier to follow what who's that? Sorry, I'm sorry. Apurv does. He takes the total number of cases, 6 power 4, right? And then he wants to pick. Okay, first 6 power 4 is the total number of cases. Now we want to have 2 distinct numbers, right? We want to pick what A should be. We want to pick what B should be, the values. Okay, so we are picking 2 different values, right? So, or rather, let's pick the first value. We have 6 ways of choosing the first value. Having decided that value, which are the 2 spots in which you're going to put A? Among the 4 spots, there are 4 spots. I'm talking about AABB wala case, right? I've picked the specific value of A that I want to repeat is, let's say, 3 or something. So I want 3. So should I have 3 here and here, or here and here, all that, right? All the different combinations. So I have 4 choose 2 ways of deciding which are the 2 places where I want to put my first chosen number. That's 6 ways. 4 choose 2 is 6. Having done that, now I'll have to select one more number, which is a different number than what I selected. Let's say I end up selecting 5 for B. And then there's no choice left for me. The spots are already decided. So I don't have anything. I just have 1. Okay. So this is the number of cases for AABB. Do you guys agree? I'll pause here for a second. Just AABB. Okay. I assume that's yes. Okay. All right. So that's AABB. Now let's do the same for AABC, right? So which means, again, the total number of cases is 6 power 4. Okay, so 6 power 4. So first, let me select which are the 3 different values. I want an A, I want a B, and I want a C, which are all different, right? So I'll select my A. I'll select and keep. I'm not putting it anywhere. I'll select my B and keep. I'm not putting it anywhere. I'll select my C and keep. I'm not putting it anywhere. Okay. So I've only selected these 3 values right now. Now, having done this, what should I do? So let's put an example. Let's say I've selected A as 3. I've selected B as 5. And I've selected C as 1. Okay. Now, 3, 5, and 1 are my chosen ones. Now, of the 4 spots, I'll have to pick I'll have to pick 2 spots which will have the same value, correct? I'll have to pick 2 spots which will have the same value. Okay. Now I take it a little back. So I'll just say I'll have to select 3 different values, and I decide a priori that my first value that I choose will be the repeating one, will be the one which will appear twice. The other 2 will appear only once. So first I get to select one number which I know ahead of time that will repeat twice. So in my case, I've decided that my number will have 2 3s and then 1 5 and 1 1. Okay. So I've selected in 6 ways, I've selected my special number, which will appear twice. And then the next number in any of the 5 ways, next number in any of the 4 ways. Having done this, I already know my selected number is 3. I just have to decide which 2 spots that the first selected number, namely 3, should go to, right? Which again is 4 choose 2 ways, which is 6 ways. You guys agree? Okay, so the sum should be, so 6 into 5 into 4 into 4 choose 2 is 6. So here also I'll replace this 4 choose 2 with 6. Okay, so this is 6. Okay, and let's simplify and let's add and see whether we get the same answer, 13 by 18. So what are we going to do? We are going to do 7 by 72, which we already did. And then we are going to add this number and then see whether we get the same answer. So first, let's simplify as best as possible. So 6, 6 is 36. So this is 6 square. 6, 6 cancels, 6 square. So we have 20 here and a 5 here, right? So we have a 25 over 36. Am I right? 25 over 36 to be added to this 7 over 72. So let's add. and see whether we get the same answer. If not, something is wrong. We can discuss. So 25 over 36. Okay, so let's see when we add, what do we get? We get 72. Do we get the same answer or we don't? 39, no? 14 plus 25 is 39. 3 goes 20. Am I right?
So
Is
don't
it-
you need to 25 into 2? So
25 into 2Q?
because combination.
Oh, sorry. Yeah, so I multiplied the wrong one by 2. Yeah, this one needs to be multiplied by 2. Okay, so 20. I multiply the 7 by 2 instead of multiplying this thing by 2. Yeah, 57 by 72. Does that simplify, guys? 57 by 72?
I
No,
think
right?
19 upon 24.
Ooh, okay. What is wrong then here, guys? 19 upon 24.
So,
Oh, Aditya, you had your hand up. Yeah, go ahead, Aditya.
So like I did the same thing till like I did exactly 3, exactly 4. But then like when I was trying for exactly 2, what I did was I did 1 upon 1 into 1 upon 6 into 5 upon 6 into 5 upon 6. So that accounted for AABB also.
Okay, so 1 into
1 upon 6 into
so
5 upon
so
6.
so you're forcing the first two to be same AA
Yeah.
types.
Yeah, and then into 5 upon 6 and into 5 upon 6, which also gives you 25 upon 36. So that also accounted for the AABB case, but it didn't give me the same answer like we got.
So 5 upon 6 times 5 upon 6, explain the 5. So you choose a B, which is different than A. And then what is this 5 upon 6? Again, you want this to be.
Yeah, so it can be B or like or any other thing. So like that accounted for the
No.
AABB case, but then I don't know
But-
why that's wrong.
No, why the last 5 upon 6? I don't understand.
So because
Sir?
it can be any of the 5 numbers, right?
Any of the 5 numbers, as in except A, you mean, or except what?
Yeah, except A. So like when for the AABB case, instead of doing another separate, step for them, I just integrated that into this one. So like
Okay,
when you do 5 upon 6, you can get both those cases.
but if you do AA, BA, so that gets already included in exactly 3, no? Aren't you double counting there? Suppose you gave the flexibility, the last one could be any of the other ones other than B, you said, right? Did you?
Sorry, sir.
So I'm still not understanding the 5 upon 6. The last 5, just 1 second, Rohan. The last 5 upon 6 could be anything other than B or anything other than A.
Anything other than A.
Anything other than A. So which could be B and anything else also.
Yeah.
So it could be C. Okay. But the number of ways of arranging will differ, no, in the both cases. Hold on to that just 1 second, Aditya. Rohan, yeah. Were you able to find a mistake in what we did?
Yeah, so it's exactly what you just said. The number of ways to permute it will differ. So you can't do that because then what will you multiply it by? You can't multiply it by 6 because you don't know the value. They're assuming that B and C they can be the same or different. So that doesn't make sense. So you have to split it into 2 different cases.
Yeah, because one is AABB. There are 6 ways of arranging this, right? So, and then the other is, how many ways here? Yeah, it's different, right? At least I can see it's different, right? But what's wrong in what I did? Anyone? If not, I'll think over it after class and then get back. Clearly, something is wrong. It's good that you did a different method and then it's not adding up. Okay, so clearly there's a flaw in what I'm doing. I'm not able to spot it, but the easiest way would be this. So this is very straightforward, right? 1 minus all 4 have different values. There's no doubt about it at all, right? Therefore, this I can be assured that it's right. So in the next expression, exactly 2 में कुछ गलत कर रहे हैं हम लोग. Okay, I'll revert. Aditya, I know you're also not fully convinced. I'll revert to you also. Okay, on your method. Okay, but yes, it's good. I like these discussions because combination, if you like, I've told it a few times, right? Always try to do in multiple ways. If multiple ways answers match, you feel very confident. If they differ, then you'll learn what all ways you can do mistakes so that you won't make them again. Okay, cool. So that was question 2. Question 3. Yeah, question 3 was an interesting one. Okay, anyone on this one? Shivank, your video is off. Did you get an answer on this one, Shivank? Shivank, are you around? Okay, all right. Sanvi. Sanvi Seth, are you there?
Yes, sir.
We're able to do this one.
So my laptop is still broken. They broke the keyboard too now.
That's
I
fine.
still haven't gotten it back. I don't remember how I solved this.
Sorry, your laptop is broken, and so what? You're not able to see what we are doing in class right
No,
now? Or?
so I don't remember how I solved the third question.
Okay, but you should have your notebook workings, right?
So I did it on my laptop, like stuck. So I just wrote on that.
Okay. I don't know how you guys are able to do some problems like this. If it's writing some essay or something, it's easy to type it out. Doing problems, I don't know, maybe I'm old school. I still recommend pen paper, right? Obviously, you can transpose it later in your PDF or whatever, if you have to submit something. Anyway, I leave it to you.
Yeah, I'll do it on pen and paper next time.
Yeah, and more importantly, make it whatever is easy to bring the discussion to class. Otherwise, like, you're losing the opportunity to discuss something you've done wrong or show that you've done it right. Both of those. Okay, Veer, we're able to do this one.
No, so I had exams.
Okay, all right. Aditya, how about you? Your hand is up. Yeah,
Yes, so I got 660.
616. That seems like a very small,
660.
like this, 616.
No, sir, 660.
Oh, 660. Okay. Still, it seems a small number for this problem. Okay. Any others? Arav? Sharma?
I started with this one, but then midway through, I realized that my number was too small because each participant themselves could have like up till 6
Good.
questions, and then they would all. So I wasn't sure. I didn't understand the scope of the problem.
Okay, that's fine. But you started off on the right note, right? So each participant has. So what she's saying. Okay, let's list out the 3 games: A, B, and C. Right? A, B, C are the games. These are the games, and there are. I'll put small letters for the members, right? So P. I'll just. Do we have enough space? P. Okay, all right. So P, Q, R, S, T, V, W. Okay. Okay, so these are the 8 members, right? Now, the 6 that she's saying is, if I look at P itself, P itself can either take just A, or just B, or just C. Or maybe I'll do a separate one for P, right? So P with A, B, and C. So these are the choices for P, right? So just P. So P alone comes here. So he has multiple options: just A, just B, just C, or A and B, or B and C. Okay, or A and C. That's the 6 you're talking about, right, Sharma? Okay, so these are the 6 ways in which P himself can choose. Okay, so if the problem were a much simpler problem, saying each person can choose exactly like what it said, each member has to join at least one of it, but cannot join all of this. Given the club has total of 8 members, and suppose this sentence was not there, and there's at least one participant for each activity, then the answer is very simple. Each person has 6 ways. Therefore, it's 6 power 8. Agreed? So in other words, P can end up choosing the games A and C. Q can end up choosing the game just A. R can end up choosing the games B and C. S can end up choosing just the game C, and so on, right? So each one of them has one of the 6 possible ways, and therefore it's 6 power 8. And each of these members are different people, right? So each of them has the people are also different, The games are also different. It's not like the chocolate distribution where the chocolates are identical. The people are different people and the games are different games, right? So it's 6 power 8. In that case, if I delete this one small phrase, are we in agreement till here? Okay. Anyone disputing this one? Okay. All right. So so I think this is how far you got, Sharma. You know it's 6 and therefore it's 6 power 8, correct? But this extra phrase is really notorious, right? There's at least one participant for each activity, which means what? Which means suppose I end up getting P is A and C, and Q is A, and R is let's say what should I say? Just C, and S is just A and C, and so on. All of them. There's no B at all. In none of them, there's no B at all, right? There's no B anywhere in the 8 people. Then that's bad, right? So of the 6 power 8, there will be a few cases where there will be no B at all. No one has registered for the game B, right? So that's a problem. Also, there will be some cases where all of them prefer the game A. Everyone has registered just for game A, nothing else. All the way till U, V, W, whatever. Like all of them have just registered. In that case, both B and C have no enrollments at all. Both the games B and C have no enrollments at all. So therefore, we have to do some subtraction and we have to do some intelligent subtraction. We should not be double counting because all of that complication is there, right? So how do we subtract? Let's again split into cases. Do we all agree so far with that we have to roughly subtract something from 6 power 8? And broadly 2 cases where everyone has signed up for exactly 1 game and everyone has signed up for exactly 2 games, right? Exactly 2 means the same 2 games. Okay, so one category is all of them register for A, for the game A. Okay, and then I can multiply with this by 3, right? Because all of them registering for A. Similarly, it will be all of them registering for C, for all of them registering for B, right? So there'll be times 3. In how many of these 6 power 8 possibilities will there be where all of them have registered rather only for A? All of them have registered only for A, right? How many of these possibilities will there be? Apurv. Okay, actually, Apurv, you have at least participated in something. Drishit, you've been quiet today. Drishit, how many of these 6 power 8 will be where all of them have registered only for A and nothing else?
So I'm not sure on this one.
Soch ke batao na. So it's just like a puzzle type of thing we are discovering. You understand the discussion so far, right?
I understand.
Okay. So just think through and tell me. Even if you don't have an answer, at least how to approach. How many of these 6 power 8 will there be where all of them have registered only for A?
So won't there just be one case?
Exactly. Yeah, just one case, no? Literally A. That's it. Does it make sense? So some of the answers are very obvious, right? So just one case. There's only one case where all of them have registered for 1. And therefore times 3 because similarly for B, similarly for C. So there's 3 cases where they've registered only for A or only for B or only for C. Yeah, does it make sense, Drishit?
Yeah.
Okay. Now we have to do the cases where all of them, or rather, okay, how shall I say this? There's registrations only for A and B. I don't know why I deleted this. Okay, fine. All right, fine. So this is just A, just B, or just C. It's total of 3. Okay. Now registrations only for A, B. Okay. So this could be like P is registered for A, Q is registered for A, B, right? R is registered for A, S is registered for B, and so on. But there's no registration for C at all. At the same time, it's not like everyone has registered for A, right? So, yeah, go ahead, please.
I think there will be
Sorry.
Yeah, sorry, some girl was answering. Who was that? I forgot. I mean, I couldn't recognize. Ananya, go ahead, please. Yeah.
Yeah, I think it'll be 24.
24. Why 24, please?
So because there are three options, a person can either register for A or AB or only B.
So
And into 8.
Just 1 second, Apurva. Okay, so only A we have. Oh, okay. So you're saying each person has 3 options, only A or only B or AB. Okay, therefore you're saying 3. Then if that's 3, then why is it 3 into 8? It's 3 power 8. Is that what you mean?
Okay.
No, not because I say. Why are you multiplying 3 times 8? So you're more or less on the right track. So it's 3 power 8 in that case, no? Agreed? Okay. But hold on to that. There's a small possible flaw there. Apurva, you were saying something?
yeah, so I thought like 3 to the power 8 only, right? But I guess if you're counting along with the A, then you subtract the one case where it's only A. So then you get
Because then you'll have to subtract 2 because even it can be only B also.
Exactly. So collectively, both of you gave the correct answer. So it's 3 power 8 will be the cases where every person is registering either A or B or AB combination. So it's 3 into 3 into 3, so on till 3 power 8. But from this big list, we have a few cases where everyone has registered only for A. We don't want to double count because we have already eliminated that. Everyone has registered only for B. We also don't want to count them. Okay, so there are 2 cases where it's only A or only B, which I want to subtract. Okay, well done, Ananya and Apurva. Okay, good. So therefore, similarly for BC combination, similarly for AC combination. So I'll just take this number and multiply by 3. Right? So finally, what am I saying? From the 6 power 8, I'm subtracting 2 numbers. 3 is one number, or rather 3 times 1. This is the 3 times 1. And then 3 times 3 power 8 minus 2. Okay. Numerically, what it is, I'm not interested. So anyway, if at all we have to subtract, it's 6 power 8 minus, how much is this? 3 into, okay, 3 power 8 minus 6 plus 3, right? So 3 power 8 minus 3, something like this. Okay, but definitely is a much bigger number than 660, right? Does it make sense? Aditya, was that you? 660?
Yes, sir.
Yeah. Okay. But does this method make sense, guys? All of you?
So if this sum comes for the AMC exam, how will we solve it without a calculator?
No. See, say I picked it up from some other exam where there was no choice at all. In AMC, obviously, there'll be choices. And the choices will have different variants of 6 power 8, 3 power 8, all of this. Guma, they'll have different things. So you won't be expected to solve a numerical value for it. Right? You just have to spot and identify which one. Okay, makes sense? Everyone understood this? Kunsh, you're convinced about this? Veer, you're convinced? Sanvi? Okay.
Yes, sir.
Okay. Next question. 3 for question 4. Okay. What is the probability that sum of 2 values adds up to the remaining one? Okay. Navya, what did you get on this one?
I got D.
D, 5 over 24. Is this something that we did recently? Again, this also faintly rings a bell for me. Not sure of recent homework. Anyone else? Arav, what did you get? Apurva, you were saying something? Apurva, did you say something?
yeah, I said I got 5
You
by
got the
20.
same? Okay. Okay, Arav?
So I got D.
D, which is 5 over 24, no?
Yes.
Oh, okay. All right, cool. So anyway, let's quickly do it. Number shown on 2 of the sum as to the third one, right? So without loss of generality, let's say A plus A, B, and C. Let's say A plus B adds up to C. And then we can always mix around those cases, right? So we can start with, we can keep it in ascending order. So we can keep like this, right? A is less than or equal to B. Okay, so 1, 1 adding up to 2. 1, 2 adding up to 3. We don't have to list all of them all the way till 1, 5 adding up to 6. Okay, this is one cluster. And then can start with 2, 2 adding up to 4, go all the way till 2, 4 adding up to 6. In fact, there's only one before this, I might as well write. And then the third cluster is just 3, 3, and 6. That's it, right? Now, so the total number of cases is 6 power 3. Okay, now we just have to see how many of these cases there are, right? So you have to be careful. So numbers like, suppose it's 1, 5, and 6, where all the three numbers are different. There can be 3 factorial ways of arranging them. It could be 6, 1, and 5, 5, 6, and 1, anything, right? So there are 3 factorial ways of numbers of this kind. So where all the 3 numbers are different, which will apply for everything except the 1, 1, 2 case, where 2 numbers are same, only the third number is different. There's only 3 cases in this case, right? Because the 2 can be in the first place, second place, or the third place. Everything else is 3 factorial ways, where all the 3 numbers are different. So how many of them are here? So 2, 3, 4, 5. There are 4 of them here. So there are 4 of the 3 factorials here. And then there's one which is just 3 ways. Similarly, this guy would appear in 3 ways, 2, 2, 4. And these 2 will appear 3 factorial ways. And this guy would appear only 3 ways. So now just adding up. So 3 plus 3 plus 3, which is 9. And then 3 factorial into 6, right? So 3 factorial is 6, 36 into 6 is 6 into the 6, which is 36. So it's 45 by 6 cubed. Hopefully that will simplify. Let's see. Right? Does it simplify, guys? So 3 goes 15 times. 3 goes 2 times. 3 goes 2 times. 3 goes 5 times. So 5 upon 24 indeed. Okay, any other method? Navya, did you do something else to arrive at the same answer?
I just did like the way you can add up to 6. The ways like imagine one dice gives you like the sum is 6 on one dice, and then the other 2 there are like 5 ways which you can get 6 from the other 2. Then same for like the rest. And then I multiplied so I got 5, 4, 3, 2, 1, which is 15. And then I multiplied it by 3 to get 45 and divided it by 6 cubed.
Yeah, wonderful. Maybe that in a way it's actually I feel easier. So she's starting with C. So the total can at max be 6. And then she split it as 1, 5, 2, 4, all the way till 5, 1. Right? So, and then but there'll be 3, 3 here as well, right? So there are 5 ways here. And then you multiply the whole thing by 3, is it?
Yeah.
Okay. So you're saying you'll put the 6 somewhere. It can be the first place or second place or the third place. The other 2 can be the ordered pair that you have given here. Okay. All right. Makes sense. Okay. Similarly, 5 kile, there'll be 4 ways. So all of you convinced in her method as well? Is anyone not convinced with her or did not understand her method? All of you okay, right? Yeah, it's important to understand multiple ways. Shivank, you also got 5 over 24 on this?
Yes.
Okay. Question 6. Okay, circle problem. Okay, Drishit, were you able to do this one, or I forgot some of you had exams? I'm sorry if I'm asking you again and again. Did you have exams or you were able to do this one, Drishit?
So like I'm having a problem with like this topic overall. So I don't know, I'm getting the first few sums, but then I'm just not understanding. So I need to work.
Yeah, just work on it, but just develop the confidence yourself. In a way, permutation combination is one of the easier topics because it's just logic, right? You just have to put yourself in that situation and just think you're playing a game. This is happening, that's happening, and then you just walk through those steps yourself, right? Of course, this one is slightly on the trickier side. Anyway,
you missed question 5.
Oh, did I? Okay, already I pasted this one. Let's discuss this and then we'll go back to 5. Yeah, thanks, Kunsh. Okay, let's discuss 6 and we'll go back to 5. Okay, this one, Kunsh, did you get an answer on this one? Okay, Apurva, yeah, go ahead.
So I got 1 by 4.
1 by 4, okay, all right. Anyone else?
Sir, even I got 1 by 4.
1 by 4, one as well. Okay, okay, let's do it. So I'll put one big circle here. Okay, I don't know how to put another circle which is concentric. Okay, so I'll put another circle which is, if I do this, I cannot move it. That's the problem. Okay, maybe I'll just start with here. Sorry guys, 1 second. I'm trying this. Should work out. Good. Okay, all right. So I have two circles, right? One is radius 1, one is radius 2. And then what is the probability that the chord joining the two intersects the circle? Okay, so without loss of generality, I can pick one point as the bottommost point. Okay, the first point as the bottommost point, because I can always switch around the circle, right? Arya, your hand was up. Yeah, go ahead.
So I found my answer. I got 1/3 for this.
1/3 for this. Okay, all right. Navya?
So what do you mean by without loss of generality?
Oh, meaning, okay, that's a phrase which is always used. I'm not making any false assumptions in saying I want to. Not false assumptions. I'm not doing a mistake in saying the first point is at the bottommost of my picture. Because let's say it's not the bottommost. Let's say it's here. I can always twist around my circle and say now it's at the bottom. So I'm not losing any. I'm still keeping it general. That's what I mean. Does it make sense?
Yeah, got it.
Right. Okay. So my first point is at the bottommost here now. Okay, but Navya, you also got 1/4 or 1/3, or did you have an answer on this?
No, I didn't get this one.
Okay, fine. Okay. Now, what he wants, what is the probability that the chord joining the 2 points intersects the circle? So which means he's okay with a line which is passing like this, right? Which cuts through like this. Okay. So this will be an okay line, and the line which will not be okay will be something outside of this, right? So something which is like this is not to be counted. Okay. All right. So we all agree that. So the extreme case would be when it just graces through the chota circle, right? The small circle. So let's draw the just extreme case. So the extreme case would be when it just graces through tangentially. Okay. And since there are infinite points, so it doesn't matter. This, relatively speaking, the probability of it just being tangential will be 0, even relatively, right? In fact, for any particular angle itself will be 0, but collectively all of these zeros will add up. All of these small numbers, I shouldn't say zeros, will eventually add up to some substantial quantity, right? So it's in proportion, it's continuum. And then there are two continuums. The second point can be anywhere. And relatively, where is it placed? That's the question, right? Now, and on the other side, it can go all the way up till here. Right. So now let's complete some diagram here. So this, if I obviously from the center, let me connect here. So that I have a tangential point. So this is 1. Okay. So I have the famous 1, 2, 3 wala logic, right? So this radius is 2, and this is 1, and this is 90. Therefore, this is √3, and therefore this is 60 degree. Right. So this angle is 60 degree, which means this angle at the center will therefore be 120 degree. Right. Sorry. So 120 degree. Okay. So okay, forget what I'm saying. Okay. So this is 120, which means every point in this stretch, right, will cut. Correct. Every point in this stretch will cut. Okay. And every point in the stretch means if I choose the second point somewhere in the stretch, if I pick my second point here or here or here or here or here, the chord is going to cut. Okay. Now we just have to find what proportion this is of the entire circle, correct? Now that's easy, right? Because if this angle is 60, so we can say, okay, let's see. Okay, let's do it this way. Okay, this angle is 30. This angle is 30. Then it is the center O, right? So angle at the center of the circle is twice the angle at the periphery. So which means this angle will be 60. Do you agree? This angle will be, 120. This angle will be 120. Why? Because it's double of this angle, which is 60. So ignore the other. Okay, so just focus on this one. This is 60 degree, and therefore this angle will be double of that, 120 degree. Agreed? So we have flexibility of choosing the second point anywhere in the 360 degree, right? But it's only this stretch of the entire 360. So it's 120 out of the 360, which is indeed 1/3. That's the stretch that's favorable to us. Yeah, well done. Was this Arya or Arav who got it? Arav, 1/3. Okay, does it make sense, guys? Okay. Should I discuss the 1/4 if you guys have something to share and not able to find the mistake? I think 2 people got 1/4, right? Do you want to?
I didn't think of this at all. Like I did like I just said like I took the ratio of the like I took the ratio of the areas, right? And then since that's 1:4, the probability also becomes 1:4. I didn't do anything like this. I thought it was like
okay, but does this make sense, Apurv?
yeah.
Okay, cool. Rohan, makes sense, right? Okay, so there are a lot of problems based on this circle. One other problem you can try is also try it later. We can discuss next class. I choose 3 random points on the periphery of a circle. 3 random points on the periphery of a circle. Only one circle. Okay. What is the probability that the triangle that's constructed using them is an acute angle triangle? Okay, you understand the question, right? So I select 3 random points. So let's say I select here, here, and here, 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 and here. Okay, I form some triangle. Okay, let me just not draw it. I didn't mean to draw it equilateral or anything. So let's select this point, and this point. Okay, so this is one such triangle, right? So maybe this is slightly obtuse. Maybe this is 91 degrees or 92 degrees. I don't want this. I want an acute angle. What is the probability? This acute angle triangle. Okay, try that and we'll discuss next class. Okay, question 5. Thanks, Kunsh, for reminding that. Question 6, all of you convinced on this? How to do this problem, the circle?
So I have one question.
Yeah, Arav.
So what if the first point was placed on a different location in the circle? Wouldn't there be more?
No, that's what the without loss of generality was the first one, right? Wherever I choose the first point, I'll move my circle and then get it to the bottommost. See, or rather, wherever you choose the first point, there'll be correspondingly a 120 degree wala segment where it'll be favorable to you. So it literally doesn't matter where you select the first point.
So basically, it's always going to be 120, right?
Exactly. Yeah, correct. Always going to be 120, right? So in other words, so if you select, something like this, and then so this is, the other circle is like this. Okay, and if I select the first point here, so it doesn't matter. This stretch from here to here, this stretch will again be 120 for the same reason. I just have to tilt my face, I'll see this is 120. So, which is why I said this statement, without loss of generality, I might as well assume a convenient location for me to solve the problem, which is the bottommost for me, or topmost, anything. Yeah, okay. So question 5. Let me paste it. Okay, Kunsh, since you spotted it, which means I think you got an answer on this one, which is why you want to show off. Right, Kunsh?
No, sir.
Okay, fine.
I
show
got
off.
confused by this question. So
okay.
That's why.
All right. Do you have an answer at all, Kunsh, on this?
So, because I feel like the answer should be just 3/8, and the middle sentence should not matter at all.
Okay, 3/8. Okay, all right. And then okay, we'll discuss. And then any other answer, Apurva?
So I'm not sure because I don't have my working, but I got 1/10. I
1
don't
over
know, but
1/10. Okay. 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 So you're saying 3/8. So what is the logic there? Accidentally, one ball is lost. Not knowing this, draws two balls and observes that both are red.
Yeah, but how does that matter? So that he observes takes two and then observes that both of them are red. Because no matter if a red or a blue is taken out, there's still a chance for it to be 2/red, right?
Okay. Okay. So you're saying it just depends on the proportion of this 3 upon literally 3/8, as simple as this, as simple as this.
Yeah. Because maybe it's a misunderstanding on my part. I don't see how it matters.
Okay, it will matter. I'm just trying to see whether I can give a very simple counter example. Okay, the red, what's the probability that the last ball was blue? Okay, okay. Let's take this case. Instead of, I'll just say 2 red balls and 3 blue balls, right? So I'll replace this problem with 2 red balls and 3 blue balls. Now read the problem again. Accidentally, one ball is lost. Not knowing this, Shankar draws 2 balls and observes both of them are red. What is the probability the last ball was blue? Isn't it 1? Because if I'd lost the red ball, then I could have not got 2 red balls. Correct?
Right.
So in this
I
case,
understand that.
Yeah. So in this case, by your logic, it should be 3/5, right? That's enough to prove that it does matter. Instead of 1, you're putting 3/5, which is wrong. Does it make sense?
Yes, sir.
No,
Yeah.
all I'm saying is I'm giving a counter example where your logic of just a proportion of this will not work. Okay.
Right.
Yeah. Okay. All right. Now, yeah.
So I just got half.
Half. Okay. All right. So yeah, 3/8 might still be the right answer for a different reason, Kunsh. Okay. But 1/10 seems very small, no, Apurv? So 5 red balls and 3 blue balls, itna bhi kam nahi hai. So that's 1/10 is very low probability, I feel. Intuitively, it feels low. Okay,
yeah,
Aditya.
I'll try to find my working.
Okay, Aditya, what did you get? Your hand is up as well.
2/7.
2/7. Okay, all right. Let's discuss, right? So there are 5 red. Okay, I don't want to use either red or blue so that it's not. Okay, so 5 red and 3 blue. Okay, and then you lose 1 ball. Okay, so I'll say lost blue is this section, and then you lost red is this section. Okay, so if you lost a blue, then you end up getting 5 red and 2 blue. And here you lost a red, therefore you end up getting 4 red and 3 blue. Okay, now if you're picking 2 balls from here, so what is the probability of you picking 2 reds from here? Probability of 2 reds from this point on is how much? It's 5 choose 2 upon 7 choose 2. Agreed? So suppose we land up here, the probability of picking 2 reds is 5 choose 2 upon 7 choose 2, which we can do it easily. 5 into 4 by 2 upon 7 into 6 by 2. Okay, so let's keep 20 upon, I'm not simplifying because similar expressions you're going to get everywhere. So let's keep it as it is, 20 upon 42. So this is the probability that if you lost a blue ball, then what is the probability that you're going to pick 2 reds when you pick next? Okay, similarly on the lower branch, suppose you lost a red ball and landed up here. What is the probability of picking 2 reds here? Okay, so this previous word was P, right? P of 2 reds. Okay, so P of 2 reds here is 4 choose 2 upon 7 choose 2, which is 4 into 3 by 2 upon 7 into 6 by 2, which is 12 upon 42. Okay, now, so find the probability the last ball was blue. Okay, so essentially we are asking this branch was what fraction of the upper branch plus the niche branch. Relatively speaking, what is the probability that the top one happened upon the top plus bottom? So we want top upon top plus bottom. That's what Bayes' theorem is essentially also saying. I'll just recap it with formula also. So what is the probability that the top occurred given either top or the bottom occurred? We know that one of these two events happened because we ended up picking two reds. That's for sure. Either the upper branch happened or the niche branch happened. Yeah, Arav, your answer is your hand is up. Yeah, Arav.
I just solved this using Bayes' theorem and I got 3/5.
Okay, 3/5. Okay. We'll do using, but this is Bayes' theorem essentially. But let's see, right? What is the probability of him losing a blue? Losing a blue is 3/5. What is the probability of him losing a red? Is 3/8. 3/8. What is the probability of him losing a red, the bottom branch? 5/8. Okay. So which are the key probabilities here? So 3/8 and 5/8 is the probability of you losing a blue or losing a red respectively. Having done that, 20/42 and 12/42 are the respective probabilities for you to pick two reds. So the upper branch ka full probability is 3/8 into 20/42. Okay, that as a fraction of 3/8 into 20/42 plus the niche branch is 5/8. I'm sorry, guys, this is too cluttery here, right? Maybe I should just move it up a little bit. Just rewrite it. So the upper branch is 3/8 into 20/42. The total is 3/8 into 20/42 plus 5/8 into 12/42. Okay, so relatively speaking, and I'll come back to you on the Bayes' theorem. It's exactly same. So 8 and 42 can get cancelled. So it's just 60 upon 60 plus 60. So it's indeed 1/2. Yeah, Navya, well done. Okay. Navya, you have a doubt? Your hand is up.
I had a much easier method to do this, and I didn't use our calculation.
Okay, go ahead, please, Navya.
So, like, assume you have 5 red balls and 3 blue balls, and then they said that eventually you pick up 2 red balls at the end, right?
Yeah.
So, the missing balls could have been 3 red or 3 blue, and then there's an equal probability for both of them to be missing.
Say that again once more. The missing balls could have been.
So, if the initially 5 red and 3 blue, and then you've picked up 2 red balls, then that means that the amount of, like, there's a half equal probability that the lost ball was red or blue, because you already have 2 balls which are assured to be red. So then if you subtract that from 5, so 5 minus 2 is 3. So that means the missing ball could have either been like 3 red balls or 3 blue balls, which is just half.
Not fully convinced. So you're picking 2. You're saying it's 2 reds. Okay. But the picking has happened after you lost that 1 ball.
No, so like if basically you guarantee that the balls which that the missing ball, it was not like one of the 2 red balls, because that you've already picked up.
Agreed. Okay, you lost a ball and then you picked up 2. You see they are both red. Okay, now again start over after that.
So that means that the amount of red balls, that like the probability that the red ball was lost was 5 minus 2, because like you picked up 2 red balls, so it can't be the missing ball.
But isn't it being lost before you pick it up?
Yeah, that doesn't matter though. Like if it's lost and if you can't pick up the lost ball, because it's what's in your hand. I'm not to explain it, but
no, I hear you. I'm just wondering, will it always work? Okay, we can try a different set of numbers and see if it works. Somewhat okay. So basically, in this case, because the numbers were such that 3 and 3, you could immediately infer it's half. Suppose it had been 7 red balls and 3 blue balls, you could not have done this approach. Correct?
you could have still, right? If there are 2 red balls which you pick up, then you get 7 minus 2, which is 5. So 5 red balls and 3 blue balls. And the probability that the lost ball was blue will be 3 divided by 5 plus 3, which is 3/8.
3/5 plus 3. Instead of 5 red balls, had it been, so it'll be 3/8. You're saying, okay. Okay, let's try this. Suppose if it's so you're saying if it's so what are you saying? If you're saying if I replace this question with 7 red balls. Okay, 7 red balls and 3 blue balls. So according to you, your answer would be how much? 3 upon 8, is it?
Yeah.
3 upon 8. Now, according to what I did using Bayes theorem, so what will it be? So probability of losing a blue would be same 3/10. This will be the upper wala branch. The niche wala branch will be 7/10. Okay. So in this branch, you end up getting you lost a blue, right? So you have 7 red and 2 blue. So the probability is choosing 7 choose 2 upon 9 choose 2, which is 7 into 6 by 9 into 8. Okay. So here, bottom here, suppose I have, so I've lost a red ball. So it's 6 reds and 3 blues. So it'll be 6 into 5 by 9 into 8. Okay. So now if I do the proportion here, sorry guys, I'll remove this clutter now. So according to Bayes theorem, this will be 3/10 into 42 by 72 as a fraction of 3/10 into, this is the 42 over 72. 42 over 72 plus 7/10 into 30 over 72. Okay, so the 10 and 72 all does not matter. So it's just that 126 upon 126 plus 210. So how much is this? Is this 126 plus 336? Is this the same as 3/8? Let's see. 8 goes how many times in this case? This is divisible by, okay. 3 goes how many times? 3 4s are.
Sorry, 42 times.
42.
42. And this is how much? 112, right? Does it further divide by
Yeah,
any
so
other number?
it comes to 3 by 8.
Very nice. 7, right? 7 6 are. And 7. Why am I not able to simplify this, guys? 7 how many times, guys?
So 7 16 times, I think.
Yeah, so 7 6 are here, right? 6 upon 16, which is 3/8. Okay, wonderful. I didn't think of it this way, Navya. Very good. Just 1 second. Just 1 second. Let me just use the washroom and come back. 2 minutes, please. Okay. All right. Yeah, well done, Navya. Sorry, someone else did Bayes theorem and got a different answer. Yeah, was that Arab? Was that you?
Yes. I figure out my mistake when I look at yours.
Okay, cool, nice. So let's try to do one more question and then we'll wrap for today. List of 11 positive integers, question 7. Yeah, Vivan, any answer on this one? Vivan is there or he's probably left. Okay. Oh, Rohan is also left. Okay. Yeah, I see some hands up. Yeah, go ahead, Apurv. Yuvam,
So I got 35.
35. Okay. Yuvam,
Sir, I got 24.
24. Okay. Okay. Navya,
I also got 35.
35. Okay. All right.
I got
So
33.
33. Okay. All right. So 11 positive integers. Median is 9. So we'll put, so there are 5 on this side and then 9 is sitting here. Okay. In the middle and then 5 on this side. Just 1 second. Sudarshan. Okay, so 9 is at the center, and then unique mode of 8, which means 8 has to appear at least twice because 9 is appeared at least once. So, and if 8 is a unique mode, 8 has to appear at least twice for it to be the unique mode. And then we want to have largest possible value of, so which, let's say this is ascending order. We want to maximize this number with a mean of 10, which means mean of 10 means the total adds up to 110. So total adds up to 110, right? So, so let's to maximize the last one. I want to keep as small number as possible here, 1, 2, 3. Okay, and then I can have one of these 10, 11, 12, and 13. Okay, so let's do this and see what we get. So let's add this 6, 14, 22, 31, 41, 52, 64, 77. And yeah, I'm coming to that. So therefore, the last one is 33, which is tempting, which is also one of the answers, right? But we can, it's not necessary that we have to have only 2 8s, right? We can have 3 8s and let's try that. And then in which case we can afford to put 2 1s. And then in which case we can afford to put 2 9s and 2 10s. And then maybe 11 here. So this will probably, we don't know yet because I'm putting 3 8s here. So the total could be less or more. Let's again add and see where we get. So 2, 10, sorry, 2 and then 24, which is 26, 35, 44, 64, 75. And therefore you have 35 here as a better possibility. Navya, was that exactly what you were going to say as well? This other possibility. Yeah. So even now, I cannot be fully convinced. I can do the same thing. I can extend 8, 8, 8, 8, but that becomes too much, right? If I put too many 8s, that's also a problem. Yes, I have only one possibility for putting a 1. And then here on this side, and I can at max put whatever 3 9s. So this sum will definitely come out to be bigger. So you'll probably get a smaller number here or something. Okay. So slight experimentation is needed. Okay, all right. So we are up on time. Do we have time for one more? No, actually, this will take some time. Okay, all right. Let's stop here, guys. We'll continue. And then from this week on, I want you guys to like full-length practice tests. I'll assign it as part of homework. Okay. So we'll have to. I'll give instructions on the homework. Okay. Chalo. See you.